Hello, everybody. We're going to give a few more minutes for folks to come on in. Hey, folks, welcome to the first CFRG interim in, well, a very, very long time, I think. Let's check the list here. Is everybody here? Questions or comments before we jump into just like a quick overview of what we want to cover here? Okay, so one thing to share before we get started is the note well. So this is official IRTF business. So make sure that you have the note well, follow it. It's all it's available on the IETF website, and it applies to the IRTF as well. If there's a specific note well for this. Yeah, hands up for Deirdre. Can you hear me?
I think Deirdre may have just been saying good morning in the chat.
Oh,
yes,
okay.
it was. Yes.
Hi, good morning.
Just waving hi.
Okay, great. So we have a lot to discuss here as well. I know the lead up to this hasn't been extremely informative, but we have a list of discussions that are going on right now on GitHub regarding the project of hybrid chems and CFRG's publication of documents towards the goal of elucidating these for IETF and others. And so we'll be talking about these, going through these, and I put together a potential list of things we can talk about in the notes, and Richard has put together some slides. So as we have 3 hours here, hopefully we don't take it all, but we're going to make sure to save some time at the end of each hour for a break for everyone. This can be a little bit intense, 3 hours. So yeah, with all that said, yeah, this is an official IRTF CFRG meeting, and rules apply as described. And so with that, I'll open it up to the group if there's any questions or comments, and if not, I can kick it over to Richard, who can get some of the conversation started. Yes, no? Okay. I can upload the slides, or Richard, do you want to share the slides?
I was about to embark on that adventure of figuring out what would work best. Do you want to try screen share first? Because that might be a little more direct.
Sure. Do you want to screen share, or should I? I can.
Oh, okay. Great, if you'd like to.
Actually, no, give it a shot right now. I will try to upload these to the data tracker, and we'll go from there.
Okay. Great, so I just requested screen share.
Okay, passing slide control to you.
Okay, it says no documents available. I think that's slide control, and MeetEcho only does the uploaded slides.
Okay, I have the slide ready to upload right now, and we can do that. Apologies to everyone for not having walked through this before.
Everyone stand by.
Okay, there should be slides now.
Oh, I see agenda slides, and that's all. Oh, maybe that's. Oh, that's right. Great. Perfect. All right. So yeah, I think as I said on the mailing list.
Actually, before we get started, I forgot
okay.
one last thing. So there is a hedge doc attached to this with notes. So if anybody would like to volunteer to be the scribe to do this, rather than going after this after the fact and looking at the recording, please raise your hand. If not, I can make some notes in here, and we welcome community participation in these notes as well. But I can post the link directly in here, but it's attached. And if no one's raising your hand right away, I can handle it for now. So, Richard, back to you.
All right. Thanks, Nick. Oh, looks like Tom volunteered in the chat. So as I said on the mailing list, we've made some good progress on this since the last IETF meeting, and just have a few open issues we want to get feedback on before we start kind of heading toward finalization. Hopefully kind of getting something in final-ish shape, between now and the IETF meeting in November. So these slides are just to kind of tee up what we've done, recap folks and level set on where we've gotten since July IETF. And then Deirdre will talk about the state of our security analysis a little bit, because we've kind of streamlined and simplified a little bit, but that streamlining has led us to cover a few extra use cases which need a little bit more analysis. So Deirdre will talk about the state of security analysis, and then we've got some questions at the end which largely correspond to the GitHub issues. So hopefully there should be no surprises if you took a look at GitHub to prepare for this. That was my agenda. So just to recap, always good to look back on what the job is we're supposed to be doing, which is producing some notes on what the right security properties are for hybrid chems, reviewing well-reviewed techniques, and then providing some concrete instantiations. And on the left, I've noted some additional things that, requirements that have come up as we go on, things like overlap with LAMPs and OpenPGP, and providing targets for convergence as people are designing hybrid chems. So this is the very clear target we have in mind as we're doing this work. And I noticed Paul Grubbs just pop up in the chat. I don't remember if, as of the IETF, we had Paul involved. I think we did, but I want to thank Paul for his helping out and joining the author team here. So that's our goal here. Kind of three major buckets of changes since the IETF meeting. We did a bunch of revision on the security considerations to make it clear and kind of make it correspond to the brief I just showed. The biggest substantive change is that we've done some, like I said, some streamlining and some covering of additional cases. So we removed pre because at the IETF meeting, in that discussion, there seemed to be not much energy for pre-hashing in the discussion there. So we removed it. There did seem to be energy for having fewer constructions. I think it was Ecker said ideally, Ecker and Stephen Farrell said ideally just one, but maybe we have to have something to cover X-wing as well. I think we have a framework that right now that is pretty elegantly covers both of those cases with the kind of minimal set of moving parts. So we'll talk about that in a minute. But hopefully we've gotten there. And when I say minimal moving parts, we realized in talking, especially with Mike Ellsworth and the LAMPS team after the IETF, that we needed a few more bits to kind of cover some corners that weren't covered in the last draft. So in the last drafts, we had the GHP and QSF frameworks. GHP, you could only instantiate it with a chem and the traditional component, not a group like an elliptic curve, which seemed like a kind of major oversight because people like to use elliptic curves for traditional key agreement and traditional chem. And on the other side, we had QSF, but it was, as stated, you could only instantiate it with a group in the traditional component. And LAMPS had actually already written out basically QSF with RSA in the traditional component, which is not a group. That's a chem. And so we wanted to make sure we covered that so that we could cover the LAMPS cases as well. So basically, I'll go into where we ended up on that in 2 slides. Just to talk briefly about the security considerations. Editorial, this is kind of based on the brief that we had talking about first the security goals for hybrid chems, and listing before that the things you need to understand in order to understand the security goals, and then providing the security analysis behind that. The thing I'll highlight for folks here is kind of the middle bit here. The security goals we've highlighted were obviously NCCA is the standard security notion. And then we want to talk about binding properties as well. The two we highlighted, we highlight in the current, what's in the repo, is these binding properties leak bind KPK and leak bind KCT. And the reasoning for that is kind of 2 parts. On the security model side, the first token in those descriptors, the 3 options are honest, leak, and malicious. The feeling was that honest is too weak a case. There's real attacks against that. Malicious is too strong a security model because it basically requires you take a private key from the attacker, which is a little outlandish in practice. And so we thought leak was the right security model target. And then KPK, KCT, the feeling was that those are the most relevant properties for protocol designers because they're basically transcript binding properties. It's things you would do with things like TLS transcript hashing that it's nice for the chem to provide for you. And so those were kind of what we ended up with as the focus for the binding properties. But interesting to hear if folks think that's insufficient or we need to go for different ones. And then Deirdre will talk more about security analysis in a couple slides. Did Deirdre want to pop up, right? Anyway, so the substantive change here, and this is the I like this kind of 2x2 matrix slide. So what we kind of realize is we've got basically 2 axes in which we need to cover provide hybrid chems. We need to cover the case where the traditional component is a group, like an elliptic curve group, and we need to cover the case where the traditional component is chem. So that's axis number 1. And we have these 2 assumption cases about the assumption we make about the post-quantum component. So either we assume that the post-quantum component is just in CCA in the best case, and when we assume in the analysis when we assume the PQ side is broken and we're relying on the traditional side, we don't make any assumption about the PQ side. It's just random bits that are handed to us. And the other case is the more QSF-like case where we assume that the PQ side has this C2PRI property, and in the analysis, when we assume the PQ side is broken, we still assume that C2PRI property. And basically that lets us make so some of the PQ bits, we don't need to explicitly hash the ciphertext and encapsulation key because that C2PRI property basically provides those bindings for us. What's nice about this, and we'll come to how we describe this in a minute, these actually all kind of look the same. You can see we've actually used the same notation in the draft for all 4 of these, even though they have slightly different semantics in the group and chem cases. Basically, if you tried to make if you did the obvious thing that people do when they try and make a chem out of elliptic curve and they make a non-NCCA chem and have an ephemeral key for the ciphertext and a public group element for the encapsulation key, that's what you end up with here. So basically, if you operate the group in that way, you end up with the ciphertext and the encapsulation key bits here. And so the combinations look notationally the same in the group and chem cases, which is nice. And so really the only difference here between the left and right columns is that you align certain things that are basically already covered by the C2PRI property. So I think this is, in the spirit of as simple as possible and no simpler. I think that's, yeah, I think we're kind of there. This is, about as simple as you can make it without, while still getting the binding properties we want, and covering the C2PRI cases that, people are interested in getting the performance PNs out of. So that's the variance we have here, the actual concrete construct, not concrete because we still have a concrete draft, but the specific constructions we have here. We'll talk a little bit later about how to write these down, whether they're 4 different things or variations on a theme. But before we dive into the details, wanted to hand over to Deirdre to talk about where we are on security analysis.
Sure. Are you driving me forward in the slides?
I can do that, sure.
Thank you. Cool. This is just a summary of where we are. Next, please. One more. Cool. Okay, so we're going to run through what we have in terms of security proofs and the requirements of the different components going into these general frameworks of how to build these kind of 4 quadrants of hybrid chems. So the thing we've been calling GHP is the most general, fewest requirements, generic construction. The proof of NCCA for this construction comes from the Chem Combiners paper from 2018. This proof is the standard model proof. It's the only one we require for both the pre-quantum scenario, where we're relying fully on the classical traditional security assumptions to give us NCCA security, and for the quantum setting, where everything is broken by a quantum computer, and we need something that will be resistant to where everything classical is broken, except, we still have our pseudo-random functions and split key PRFs and things like that, where that is the setting. So we have one proof in the standard model, and it's very simple. We just need one of the components, and this is only for chems. All the components in GHP are chems. One of them has to provide NCCA security, and we have to have a secure our KDF has to be a secure split key pseudo-random function. And you kind of squint at it, and the way you concatenate these things together, you can use pretty much any general KDF that we feel confident about as your split key KDF. And that's what the most conservative construction that we've been operating with, not just we, the CFRG, but like this is I think this is in the NIST special publication 800-227, basically the same exact construction. It's very conservative. You don't need anything from your components other than a pseudo-random function for your KDF, and your traditional component chem should be in CCA, and your post-quantum chem should be in CCA, so that at least one of them is secure, whether your post-quantum chem had a bug in it or your pre-quantum chem is no longer secure because the quantum computers arrived. This also has a nice notion because of the way we put everything into the KDF preimage. You kind of get binding properties for free. We have sketched out the proofs for getting leak bind K CT and leak bind K. I just had a typo in there. Leak bind K PK and leak bind K CT. So we bind to the hybrid chem public encapsulation key and the hybrid chem ciphertext by the single combiner, no matter what. And so, as we'll see later, you can get these properties, but it depends. And those already exist in the drafts appendix or later in the document. Those already exist there for GHP. Next, please. Cool. This is QSF. This is the framework that is used by X-Wing. This is a combination of a post-quantum chem and a group. And we need from those components that the post-quantum chem is in CCA in presence of a quantum computer. And we need it to be ciphertext second preimage resistant, even if that in CCA-ness falls apart. And we need that C2PRI security to exist in the pre-quantum setting. And then we need that group to be strong Diffie-Hellman secure. And we need the KDF to be a good KDF in 2 different settings. This has 2 different NCCA proofs. We basically have one for the pre-quantum setting and one for the post-quantum setting. The pre-quantum one is in the ROM, in the random oracle model, and we require that the group be strong SDH secure, strong Diffie-Hellman secure. The CHEM, the post-quantum CHEM, needs to be ciphertext second preimage resistant, and the KDF be a secure random oracle. The other one is in the standard model, and this is the post-quantum proof. And all it requires is that the post-quantum CHEM be actually NCCA secure, and that the KDF is a secure PRF. So not a random oracle, just a regular pseudorandom function. For binding, we have sketches for leak bind, KCT, and KPK as well, but it is completely dependent on the binding properties of that post-quantum CHEM, because we are relying on the C2PRI-ness of the CHEM to let us leave out the post-quantum CHEM's encapsulation key and ciphertext from the preimage to the hybrid CHEM KDF. It's contingent on the properties of the post-quantum CHEM, whether or not we also get leak binding properties as well. So if the post-quantum CHEM has a leak bind KPK and leak bind KCT or better, then we get that in any constructions that come out of QSF, and we have proofs for that as well in the document right now. Next, please. Awesome. So this is the first of the 2 newer kind of constructions that we've been noodling on. This is basically the GHP construction, but instead of requiring your traditional component to be a CHEM, it allows you to have the traditional component be curves and be a group similar to the style that groups are used in QSF and X-Wing. It inlines the components that you use to create an NCCA DH-CHEM, for example, but the proof is directly to the strong Diffie-Hellman security of the group, similar to we do in X-Wing, so that we can skip the extra hashing that we require to use curves in the GHP construction, exactly the same way that we do in QSF and X-Wing. And then everything else is the same. So the post-quantum CHEM, we still only rely on the NCCA-ness of the post-quantum CHEM, no extra fancy properties. So this also has 2 proofs, one in the pre-quantum setting and one in the post-quantum setting. The pre-quantum one is in the ROM, and it's very, very similar to what we did for QSF and X-Wing, which is we have to have an SDH secure group. The KDF has to be a secure random oracle model, a secure random oracle. And then the extra stuff in the construction from the post-quantum CHEM is basically extra gunk. We don't have anything about it. And because we are including the post-quantum CHEM ciphertext and public encapsulation key in the KDF preimage, we don't have to care about C2PRI-ness or anything like that. It's just extra stuff, and that's that whole proof. And then in the post-quantum side, it's the standard model proof, very similar to what we've seen in these other places. It's just the group stuff is extra gunk. We just need a secure PRF in the standard model, and the post-quantum CHEM still needs to be in CCA. We are working on proof sketches of the binding properties of this. We think that it should just be leak bind KCT and leak bind KPK, similar to GHP, because we're including everything into the hybrid CHEM KDF. We're including all the public pieces of data of the hybrid CHEM encapsulation key and hybrid CHEM ciphertext. And we know a priori from all the proofs about these binding properties that these things just kind of fall out. So we're planning to add them depending on how this specific flavor of construction lands in the actual document. Last one. Cool. So this is sort of the one that got inspired from the LAMPS work, where they wanted to include something like an RSA OAP based chem or PKE or something, but in a QSF X-Wing like construction. So this is basically QSF, but your components are two chems. You have a traditional chem instead of a group, and then the other chem is your post-quantum chem that is in CCA against a quantum adversary, and C2PRI anyway in the pre-quantum setting. This allows us to leave out its public key and its ciphertext from the hybrid chem KDF to hash less stuff. We are working on 2 proofs again for this construction. You can see a theme here. So for the traditional side, sorry, the pre-quantum side, this is, I think these are both in the standard model. Yes, these are both in the standard model. No random oracles here. We just need the traditional chem to be NCCA and the post-quantum chem to be C2PRI, ciphertext second pre-image resistant, and the KDF to be a secure pseudorandom function. And then on the other side, it's very similar to what we've seen before. We treat the traditional material as just extra junk. Post-quantum chem must be NCCA, and the KDF has to be a secure PRF in the, the post-quantum setting where the quantum computers are real. For the binding properties, we need to sketch those up, but this is similar to the QSF stuff. The binding properties fall out of the binding properties of the post-quantum chem that we include because we're not including its public key and its ciphertext into the hybrid chem KDF. We think that this will be very similar to QSF and X-Wing. So we'll get leak bind KCT and leak bind KPK as long as the post-quantum chem also has at least leak bind KPK and leak bind KCT. These are sketched up in different ways in current PRs on the repo. We have 2 different documents that are being collaborated on by myself and Mike Owensworth and Douglas Stabila and Paul Grubbs to actually publish these 4 different NCCA proofs for these different constructions. We feel pretty confident that these show these things that I've said they should show, but we need to button them up and cross all our T's and dot all our I's before we publish them and put them on an ePrint or put them in front of other people. So those should be coming hopefully soon. That's it for me right now.
Deirdre, one question before you go.
Yes.
In the chat, Mike Unsworth mentioned that the chem plus chem flavors could be useful in the future for PQ-PQ hybrids.
Right.
In the analysis we're doing so far, are there sort of would these analyses apply if you had a PQ chem in the notionally traditional components, or are there traditional things we're assuming about that side in the analysis?
So I think this last one would still hold if everything is PQ, because you can have C2PRI-ness and you can rely on it even independent of post-quantumness. So this one would still hold. Anything that relies on the ROM, like if it's in the ROM, that we might need to revisit that. So the last one, the QSH, and the first one, which is GHP, all of those proofs, you can just kind of use them whenever. So GHP is easy mode. It's just at least one of these at any time must be in CCA. And so that can be any of your PQ chems. And then it doesn't have any assumptions on the KDF that are just get annoying. To be clear, I think the ROM doesn't stop you from using that in a PQ setting. For example, like MLChem is proven in the ROM and things like that. It just affects the bounds of how many queries your adversary can make. So we would have to update the analysis. But I think out of the box, GHP and this one, QSH, are probably just straight up usable, and you can just plug and play your multiple post-quantum chems in those locations, I think, out of the box. And if I missed something, someone can correct me.
Cool, thanks. All right, so that is the end of our recap and current state of the art in the repo. We have some questions queued up here, but I want to pause briefly in case anyone has questions or comments about anything we've covered so far. All right, I'll assume everyone thinks this is Chris Patton.
Yeah, I was curious if the strong Diffie-Hellman assumption is new, or has that been around? Is it new for proving security of hybrid chems? How recently have we been proving security of hybrid chems?
I don't know if the X-Wing paper introduced it. I think you need it. I think you need it to prove inCCA-ness of DH chem, which is just a chem. It's just a chem constructed from curve groups. And X-Wing, I think, was the one in this lineage of hybrid post-quantum traditional chems that's like, we're going to explode the box of one of our chems so that we can inline the components of DH chem, because it's already like, if we just go directly into it and say, like, if we assume that this group is strong Diffie-Hellman secure, then we can just avoid the hashing and we could just inline everything. And that's literally what's also happening in that last one, QSH.
Cool.
I think that's correct. I don't recall seeing anything, but it's not a new assumption. It's just,
it's been around since the BBS paper, I think, right?
Right. Yeah.
Cool.
Thanks.
All right, anybody else? Since we have 3 hours, we can take time. All right, so I'll assume folks think we have a pretty consolidated target here, and the analysis is on its way. So we have a few questions for the group. Oh, Nick Sullivan.
Yeah, quick question. So you talked about the proofs around these and that they have to be kind of rolled up. What is the plan for disseminating these or distributing them, publishing them? What's the roadmap look like for that?
So I've been making them pretty enough that we can throw them on ePrint and we can share them widely. But even if they aren't ePrint ready, we're going to share them with the CFRG list. And we need to cite them from the document. So they'll need to live somewhere that if it's not going to be ePrint, we have to be able to cite them from the actual document to be like, yes, we have proofs that show that these things have these properties and here they live. I think that's the current plan.
Okay, yeah, and when we're through the crypto panel review on this, that they'll be able to assess the quality of those proofs and whether or not the references are, permanent or whatnot. So that's good.
Mike.
Nick asks the same question that's close to my heart. So we've got composite chems at lamps that's like itching for a working group last call, but it's waiting for this proof. And Deirdre Stabila and I have this proof that's mostly written, but we just need to touch up the security reduction bounds. And so I'm like, I need to I will really want to publish this thing. So I'm also curious what's sort of good enough. And that's going to come down to whether I'm going to fail work group last call if I try and go through without this reference. I think the answer is, Deirdre, we just need to get that thing published.
Yeah, and we need to have the reviews of our collaborators to be like, cool. If I put this on ePrint right now, are you going to be like, no, wait?
Yeah, well, we can't put it on ePrint with a giant to-do box in the middle.
Right.
We'll just take that offline.
Yeah, Scott raised one issue with ePrint is the versioning.
True.
Is an issue there. But also to keep in mind, the RFC publication process has been relatively slow lately for getting through a lot of passes. So if something comes through, that these can be updated, after last call.
Yeah.
Assuming we pass last call, which I think I'm blocked from starting a last call until we have a citation for this proof. So it's the chicken and egg problem. Anyway.
Yeah, it depends on the working group.
Yep. And there's a few other comments in the chat on this. So yeah, maybe we can reference a specific version. But overall on timeline, that's my very last slide, but I think editorially we probably, depending on the discussion here, I think we're probably good to produce a new version of this in advance of the next IETF. And at that point, I think we're maybe ready for, sending this off to the review panel, last call, whatever the next process steps are. I think this is pretty well baked. But with that said, let's dive into some discussion questions. And Chris Patton, I think you're still in a queue from before, so it might help to click that button to get out. Thank you. So the textually most impacting question is like, how should we write this up? So Deirdre and I, as we were discussing this, we both we're independent PRs, good parallel author teamwork. The way I wrote it up was as one framework, with the idea that basically you have these, everything pretty much works the same way. You generate keys, you encaps in parallel, and the only difference is this combiner function. What you put in the hash among those 4 variants that we showed. There's really only 2 variants of that, depending on whether you're assuming C2PRI or not. So I wrote this up as variations on a theme. So you choose your combiner function, you choose whether you're using a chem or a group, and you put those ingredients together to make your full construction. Deirdre, on the other hand, went kind of as she went through the proofs just now, 4 independent things. So there's a lot of repetition of the things that go together, but you don't have to kind of chase the references around to put things together. Substantively, in terms of the computations they describe, these are equivalent. So we just wanted to throw this to the group to say, like, which do you think is more readable and more usable? Thoughts? Does anyone care?
And we also got like a mini review via Nick, one of the chairs, about like, we published a guideline document about how to write things like this, and like, here's some recommendations. So that's another like input. This is not the end all be all, but this is 2 different takes of how to write up these like this kind of 4 quadrant set of ways to do this based on different kinds of components and different kinds of assumptions. So feedback on any of those axes is very welcome.
And if folks haven't read these 2, the links are available on the agenda. Do you think it makes sense to bring up the diff or bring up the GitHub page for this?
I don't actually, because these are because these are such big changes that the diffs are really kind of impossible to read. This is why I kind of tried to summarize it on this slide as opposed to going to the diffs.
Yeah, fair enough.
Well, I guess if nobody has opinions, we'll just toss a coin, or Deirdre and I'll meet in the parking lot and find it out.
So I think one thing that I would recommend here to think about this is to go back to previously published CFRG docs that cover something similar, and you don't have to follow their example. It's fine to critique the way that previous docs were written, but yeah, this idea of where do you duplicate the abstraction versus writing out the entirety of the algorithm it's an evergreen challenge in writing these specs, right? In the same way that proper software abstractions are a never-ending debate. So I know some of the previous ones we took a modular approach, and in some we just wrote out the full algorithm multiple times. So I don't think there's really strong precedent set for this. So that it's really up to the group and if anyone has strong opinions.
I think the outcome of Nick's GPT analysis was slightly in favor of number 72, but again, it's not this positive. All right, if nobody has strong feelings here, we'll take it back to the author team. We'll just make a decision.
There's a question from Chris in the chat, which is the sharp edges. He's looking for what you're trying to prevent with these changes.
I was starting to write up. So one was we had pre-GHP and QSF, and each of those were specific chem constructions, chem frameworks, where a chem is a keygen, an NCAPS, and a DCAPS. And for having each of those, we eventually wanted to kind of split out keygen a little bit when we were able to. Each of those has their own proofs and their own assumptions, and we're succinct enough to kind of lay them all out. And then we got rid of pre. So having some duplication felt okay. And then we got to 4, and then it's like, trying to figure out like, okay, do we abstract based on the component shape, which is like chem or group? And then we also abstract on like literally the security properties of the components determines what is included in the final KDF inputs. And trying to abstract them in which specific ways is kind of more intuitive. It's kind of difficult. 79 is very wordy, and we can probably, there's a lot of duplication there, and we could probably dedupe it a little bit. I think I deduped the keygen out, which helped a lot.
Okay.
But having a name for a specific generic algorithm scheme, and then you go to that section and you kind of implement the thing. We've split out the keygen because we think we can get away with that. It's kind of a boom, boom, boom. Yes, it's a bit duplicative, but I think as a specifically an engineer or specifically a person who's just like, where's the algorithm and how do I implement it? It helps with that a lot. We kind of were mixy and matchy with names and identifiers and things like that, and it kind of got a bit squishy in the other one, and then there was a bit of duplication. We've had a lot, we might get into it later, but there's been a lot of discussion of naming things and labels, because we've been trying to domain separate all this stuff in the KDF, and including names, because that identifies the generic construction in the labels to kind of help do that. So that there's like a couple of reasons kind of floating around about what 79 is sort of thinking about, but it can be made less duplicative, I think, as well. Yeah.
So would it be fair to say that 79 is intended to be targeted towards implementers and making their lives easier?
Yeah, it definitely with a where is the thing I'm supposed to implement? Now, we're aware that, of course, the generic document does not have concrete constructions in it. We're going to have our document that we're working on that has instances of concrete, and then many others, in theory, could come after. They're just pointing at the generic document and saying, we're going to use this framework to do our concrete construction. If other concrete documents had very like, here's your keygen, here's your NCAPS, here's your DCAPS algorithms in it, we could feel trusted, I guess, to kind of be a bit more, squishy, I guess. But we really don't know. We're going to write our concrete document, and we can be verbose, or we can be and duplicative, or we could not be. We could just say take thing and plug in these components, and here are some test vectors. So it's kind of yes, trying to be like, okay, if this is your document, here's the algorithms, but it's generic. So it's kind of, we can only kind of go so far,
Gotcha. So the target's not the implementers per se, it's the people who are specifying the concrete instantiations.
Well, we're not sure what those concrete instantiation documents are going to look like. So it may be always, I have a concrete document here and the generic document here, and I'm literally sitting down to code it. Or not. We're not sure.
Yeah. Well, I mean, if you look at the concrete document we have right now, the concrete doc that we have written, that we felt inspired to write as authors of this doc, was it doesn't have any algorithms in it. It's just like plug this one in here, plug this one in there. And in that case, you do end up in the framework Deirdre was just saying, where you have like, here's the list of algorithms and here's the generic doc that actually lists out the process for doing the hybrid chem. So there, I think it is, I think you're going to end up with implementers looking at this generic document. It's not just hybrid chem designers. So I think that's a reasonable perspective to take into account. And we had, I'll note just one mail on the mailing was saying that, like, from an implementer perspective, 79 seems a little more practical. But I see Chris Wood in the queue.
Yeah, thanks. I think my intuition is to prefer 72 in this particular case. I understand the objective of 79, and that is trying to like minimize any possible misinterpretation or confusion of like what exactly the generic thing is. But this really feels like the ultimate responsibility of the concrete document. Like that's the thing that people are going to look to first, I imagine, as an implementer, referencing the generic document as needed to fill in the gaps. That said, that's like purely speculative. But also this exercise has come also purely speculative because like we don't know what the concrete one looks like. So while I would prefer 72 strongly, primarily because it's succinct and it does sort of, I think, do a good job of abstracting out what needs to be abstracted, such that you could instantiate like concrete things in the concrete document as is done today. It might benefit us to just like maybe pause this momentarily and then have people actually implement it and then come back and say like, yeah, no, I found 79 better, or actually neither of them are good. Here's 84. Whatever. I don't know what the implementation landscape looks like right now. Presumably there's a couple floating around, and I would imagine that people who have implemented it did not have either of these variants in front of them to inform their implementations. So and they can't really like forget what they've learned already and then re-implement it with fresh eyes, which is a shame. But I, for example, have not yet implemented it. I can commit to doing that exercise, trying to be unbiased here. Hopefully there are other people who can do the same thing. But if ultimately if what we care about is like, benefiting the implementers, let's like have some people implement it and then follow back. Anyway, that's my 2 cents.
I think that's a reasonable bullet point for this, is to we have a short deadline, right? You want to publish this before this, but like getting at least one person to have done an implementation and provided feedback from that perspective, who hasn't done the implementation before, as Chris suggested, would be, I think, a very good thing. Yeah, how easy is it to go from just these two docs to like a implementation that doesn't have problems?
Yeah. And to clarify, I understand that there's a time pressure. I'm not suggesting we like punt and wait until the next IETF meeting. That would be silly. I can commit to trying to get an implementation done in like the next week or two, and then I can follow back. Hopefully that's good enough. But also like, I don't want to be like the ultimate like decider here. So it'd be awesome if someone else like implemented it. There are some people who I recognize in the group who, I don't know, maybe they have free time in their hands. Patton, have you implemented it?
No, but I was actually about to volunteer to do so. I should be able to find a little bit of time.
Great, I'll buy you a beer.
Thanks.
All right, well, let us know if you need help. Should we assign one of you 72 and one of you 79 and do a side-by-side experiment?
Or
I mean, jokes aside, that's not a terrible idea, because like I if you're bouncing back and forth between them, you might get a little bit confused.
Yeah. All right. So what
I don't
what
want
we
this to
do
be
is 70.
complicated, but if it ends up being like Chris versus Chris, that's kind of funny.
Yeah. So what you said you preferred 72. So why don't you work from 79, Pat, and you work from 72?
Sure.
See what happens. Um, or at least use those as your primary ones. It seems like in either case, we probably have a little bit of convergence to do. So either we start with 79 and we factor out some common stuff, or we start with 72 and we add some more explicitness. Okay, so we can let this hang fire for a week or two, see where we end up.
Awesome.
Anyone else have last comments on this one? Nick?
No last comments on this from me. If there's anyone else, I think this could be a good time to just take a break until the top of the hour,
Sure.
and then hop back into the next things. I did put together another list of kind of outlining what the open issues are. If we want to walk through that, we can, or if we want to, target particular, whatever the next slide is on your slide deck, we can continue through.
I'm gonna go ahead and put up the next slide so people consider it over the break, because this is, naming is always the fun thing.
Yes.
So everyone, go find your fruit, whatever your preferred throwing object of choice is during the break, and we'll see you in 8 minutes.
Or your favorite color of paint for the bike shed.
All right, folks, welcome back. Richard, Deirdre, do you want to host this discussion?
Yes.
I mean, do I?
I mean, I can start talking, and then we can really get into it. Okay. For the first few versions of the generic document, especially, we had 3 frameworks: GHP, PRE, and QSF. GHP, and we needed to call them something. GHP is specifically referencing the Chem Combiners paper from 2018 and the initials of the authors, Giacomo and Pottering and another person whose name I forget. So GHP is the names of the authors of that construction generally proven in that paper. PRE was literally pre-hash. It was called, there was a flavor called ChemPat in another internet draft, but it's basically, we pre-hashed the stuff, and the construction that was in there was just pre-hashing the encapsulation key, and we called it PRE because it was pre-hashing. So that was a shortener, not even an acronym. And then there's QSF. QSF is literally what it's called in the X-Wing paper, and QSF stands for Quantum Superiority Fighter. And as I blame, I didn't put in the chat, I blame Peter Schwabe, co-author of X-Wing, for all the Star Wars stuff. This is all his fault, although apparently Boz Westerbaum claims a little bit of the fault as well. So the 2 new things that we discussed earlier include QSH. And QSH is very in the lineage of QSF. It's literally QSF, but instead of a group, we allow an NCCA chem. And we show in the paper, you can just use an NCCA2 public key encryption scheme and treat it like a chem, use it like a chem, and you can use it securely in QSH. I named QSH in the lineage of QSF, and it stands for Quantum Superiority Hunter, because there's an older style of starship in X-Wing called a headhunter, and so it seemed relevant. And then HQB is the one that is inlining the group operations similar to QSF, but still only relying on the NCCA-ness, no C2PRI-ness of your post-quantum chem. And that's just another name in kind of referencing Star Wars, but not literally the same as X-Wing and all that stuff. HQB stands for Heavy Quantum Bomber. I'm pretty sure that's right. Yes, because it's similar to GHP, but not the same as QSF. So those are the names that are written down in some places. And we were trying to figure out other names to kind of encode assumptions, such as the group or the chem, because those are the 2 primary distinguishers of the types, the shapes of the components, the component algorithms, and then the assumptions of their security properties. So Richard, implicit combiner, and the
Okay, yeah, I think.
Deirdre, I think we lost your audio for the last 20 seconds.
Okay. All right. So I blame Meet Echo. M for implicit is implicitly the PQ chem also has C2PRI, and X for explicit because it's the opposite of implicit, I guess. So there's a bunch of names we've been throwing around, and the names, we try to keep them succinct, as in like 3 characters or less, because we are specifically referencing the generic framework in the domain separator label that is included in the KDF of the actual hybrid chem construction itself. So we've been trying to keep it short, but also specific. And we've been including a bunch of other names for the ingredient chems, such as ML Chem and Shake 256 or SHA-3 or whatever, in the label that we actually use to domain separate the actual computations of the shared secrets of these hybrid chems, because we don't want one hybrid chem that might be using a group and MOChem say, but using a different framework that gives it different security properties to have no domain separation, Oracle separation between it and another one that uses a different framework that gives it different security properties. So that's kind of where these names came from. We don't really have any like strong feelings. We just needed a name for a thing. That's where these names came from. Thoughts and feelings?
So in the chat, Boz says he doesn't care. Stephen Farrell says he would lose the QC names and go with the orange ones. Chris Wood says 2 is greater than 3. Tom thinks we should invite IP problems with Disney. Nick, do you want to see if you can use the show of hands tool?
Yep, I will try to set that up. Show of hands.
And to be clear, these are not our only options. These are just things that we've tried. So if other people have other better ideas, please. Or other ideas, not even better ideas.
What do yes and no mean here, Nick?
Yeah, I know. Sorry, no, it's it's submitted. I was trying to get it draft. Terminate. Okay. All right. So I'm just going to set a few up here to just say whether you're in favor, against, or neutral to a certain set of names. So in favor of the orange names first. So this is GK.
So one thing about angering the House of Mouse, X-Wing is explicitly a Disney IP and has been shipped by name in Apple Crypto Kit and other places. So I have a feeling that the IETF is not IPR encumbered by names such as those, if the group likes them. Right. Chris was saying names are important. Neither of these options are names. They're acronyms that require explanations. To me, the nuances of these different constructions cannot be summed up nicely in a good, pithy, short name. Like, it's just impossible. And so, like, for me, if we picked randomly generated 2 or 3 letter combos and assign them, I would be happy because honestly, they're just like tokens for me at this point. Yeah. Okay. No opinion.
I mean, in the difference that from top down, from my perspective here, between the orange ones and the blue ones, is that it's just easier to understand what the letters mean, and the letters are kind of one-to-one mapped to the 2x2 table in the orange one, rather than it being one entire label for the entire thing. It's similar to the last discussion too, right? I mean, it factors into what's the best way of describing these algorithms as, you know, one of a set of options, or like a 2-dimensional matrix of options.
Yeah, and I agree with Deirdre that like this is, you know, the name is not going to convey all the semantics. So these are largely just opaque tokens. I think the 2-letter ones on the slide here like give you that they're opaque tokens, but you also have some hope of getting some semantic out of them if your head's in the space.
It's interesting that Apple would use the term X-Wing in the public API. It says something about the legal concerns around here, but I don't think we can read too much into this as the IETF.
Sure,
Yeah.
this is not necessarily hold. It's just that someone somewhere with a pack of lawyers was fine with it and shipped it. So we have a lawyer. I know we have a lawyer, and they are quite good. Why we as the IETF.
As Rich Sauls notes in the chat, like Apple and Disney do have business arrangements on some things, and maybe
Oh boy.
Yeah, are you suggesting maybe they may have paid Apple to use that term for their API?
or maybe there've been some licensing.
No need to, suggest anything about business relationships. No. Okay, the results are pretty clear here. It's mostly no's for the blue and mostly yeses for the orange, although it's not unanimous. There were two. If the two folks who are not in favor of the orange names, but also didn't vote in favor of the blue names, want to step up and explain yourselves, if you will, or if there's another construction that's preferable. Anybody?
Yeah, if you like short versus long, or like there are like the fact that it's sort of like one slot encoding a thing, and it's like there's two values per slot. Is that nice? Wow.
See what we take feedback.
So I have another question here, which is more about extensibility. I mean, I think we can move on from this, but like we've gotten to the point in this discussion where it seems like these are the minimum set of constructions generically we want to provide. There were alternative ones with different types of things being prehashed in and not. I don't think those would be anything other than like if someone were to introduce those, how would they be named, right? It would be like GX prehash, something like that, KX prehash, or would it be another completely new name?
Well, I think we discussed this with Paul when he joined about like, what do we need from the prehash? Like if you're prehashing, what are you prehashing with, and what properties does the prehash hasher need? And I think we just said collision resistance. I'm not sure if we got any further than that. Like it doesn't have to be a KDF. So we had started to sketch up like, what do you need when you're trying to do
you got a prehash discussion point a little further down the line.
Right. Okay. Yeah. So
but I think to the naming point, like, yeah, you just like the two values capture these two axes. And if you got like another axis like prehashing, sure, tag that on. Maybe you have like pre-0, pre-1, 2, 3 for the three combinations of things you could possibly prehash. All right, I think we've got enough feedback here, so we can take that.
We might twiddle with the explicit values in the second column or something, but yeah. Cool.
Yeah, boss is suggesting using sorry, yeah, boss is suggesting using K instead of X. To be discussed. That doesn't change the overall discussion.
Yeah.
Okay, thanks, folks.
All right. Next, slightly more substantive issue is how do we maintain uniqueness? These domain separation labels are supposed to uniquely identify the actual concrete hybrid chem instantiation. And the usual way we do that sort of uniqueness stuff around the IETF IRTF is making a registry, such that if you use the registered labels, you are guaranteed to be distinct from other folks who are also using the registered labels. Of course, you can't guarantee anything about the whole universe, but at least within the universe of people using the IANA registry, you're guaranteed to be distinct. So the question is, should we do something here? We would make a table, probably something like what I've illustrated here. I think that's what's in the PR that I posted for this. In terms of work to maintain this, it might not be a ton of work. We might just make it a first come, first serve registry, in which case, like, you email IANA, you give them some values, put in the table, you get your label. That wouldn't even necessarily guarantee conflict freeness. You could register duplicates with different labels, and it's up to the implementation to sort it out. We could have a specification required, which would just have, like, Chris Wood and Deirdre look at something to make sure it's not, it's sane, and then sane and clearly specified, and then you register it. So neither one is a huge amount of work. So this could help us maintain uniqueness, get the domain separation benefits we expect. But it's not clear you need all the registry mechanism for this. Like, you could just say, like, dear hybrid chem instantiators, please look at the universe of hybrid chems and try not to collide with each other. Anyone have thoughts? Chris Wood?
Yeah, what happens if they collide? Does the world end, or like are people just sad? I'm exaggerating for effect. Like, surely there must be some sort of security argument as to why you require uniqueness and separation. But if it's not a security argument, then I think your suggestion of just like let them sort it out amongst themselves is fine.
Cross-protocol attacks or cross-use attacks seems to be the primary we want to separate.
Yeah, sorry, Deirdre. I mean, the concern on my end. Can you hear me, by the way?
Yes.
Yes.
Yeah. The concern on my end is exactly a cross-protocol attack where you have the same like elliptic curve key pair being used in different combiners. Like it gets really hard to reason about that. And one general piece of protocol design hygiene is just to include domain separator labels to make sure that you can't derive the same intermediate values in different calls.
Yeah, I guess to Boss's point, like it's not clear if this is like a sufficient solution to the problem.
Well, I think
an IANA registry is solution.
Sorry, just having labels in general.
Right. Labels in general are best effort because you can only guarantee that you have separated all instances of inputs to a random oracle or hash function. If you know the entire universe, it's definitely best effort. And yet we're kind of giving it a good college try, I guess.
Tom asked a good question in the chat as to whether what role these labels play in the proofs of these constructions that we're doing. So, Deirdre and Paul, did you have?
Well, almost none, because we're not. I mean, as pointed out, like the proofs are in the non-cross protocol setting. So, any kind of domain separation doesn't really come up in any of the proofs. I mean, if we wanted to extend the proofs to cross protocol attacks, then they would come up. I mean, I think it would be pretty complicated to do that, and I'm not sure it's like being roadmapped right now. But I think there has been some work looking at these kind of cross-protocol issues, but like I'm not familiar with it.
Yeah, they all assume a label, but they model, for example, they assume a pseudo-random function or a split key pseudo-random function, and in practice, having a different or random oracle. And a very easy common way to do oracle cloning is to have a different domain separator concatenated onto the inputs of your random oracle, aka a hash function or a KDF. But that is not shown in any of the proofs that we've discussed today or elsewhere. None of the literature about how do you construct a NCCA secure hybrid chem really touches on that. It's very much like, this is the good hygiene way of designing primitives or designing things with a KDF in it. If it would be very nice to see, I don't think it's in scope for us to see modeling that sort of thing in a broader protocol setting, but I think it would be out of scope for the work we're trying to do here. It's very much like a good hygiene thing. Yeah.
It makes sense. And it kind of, someone mentioned earlier in the Slack, or sorry, in Slack, in Zulu, that like higher level protocols will already have like sort of distinguishers. So like you plug this into HPKE, if you assume like only HPKE was ever going to use this, would you believe, or would you say you still needed these labels? I think the answer is no, because they're like already like the chem identifiers are the domain separator at that label, therefore like giving you the thing that you need.
Right.
But if the assumption is like you might plug this into like a non-HPKE like protocol, like TLS or something that could possibly collide with TLS or HPKE or whatever, then you want something.
Yes.
If that's the argument,
the latter. Yes.
Yeah, I think that's totally reasonable. I think this is like a really low lift. Cost of maintenance is really small. Just outsource it to an LLM or something. I don't know. And move on.
Yeah, definitely the latter. Like, at least I've been thinking of all this hybrid chems work in the most general usage possible. Like, it is a very general, the similar way that, you know, we use elliptic curves all over the place and you know, things like that. So yeah. If it were like, we are designing a hybrid chem and it will only ever be used in HPKE, there'd be a lot of things that we wouldn't even think about, because the whole system of HPKE would take care of us, would insulate us from a lot of things that we don't have to care about. And for sure. kind of similar to how the concatenation of the hybrid key agreement in TLS 1.3, we are not doing just that in here, because we have all of TLS 1.3 key schedule giving us a ton of protection and good vibes and good stuff. But we don't have that here. We have to be very kind of conservative about who's going to use these constructions. Even outside of the IETF, like the IANA registry is very much, if you're in the IETF, we get to have a little bit of control about what concrete instantiations we register, which is nice for the IETF and the things we write. But also considering that, like, it's a good faith effort to domain separate, because we can totally see people using these hybrid constructions outside of the IETF and outside of IETF protocols as well.
Yeah. Then I would say just do it. There's like no implementer cost to this. It's literally just a constant string that you like pass it. The cost is like purely borne on the people maintaining the registry. So yeah.
Thank you for volunteering to be the registry expert, Chris. Nick Sullivan.
Yeah, so if we look back at some of the previous projects undertaken by CFRG in this that are kind of comparable here, you could look at the OPRF work or the hash to curve work. For neither of those CFRG docs did they define an IANA registry in the informational doc in CFRG. It was the code points themselves were standardized inside of Privacy Pass and other protocols that leveraged this. HPKA, I think, was our first experiment with doing an actual IANA registry as part of a CFRG process. And that's the protocol that I guess is the most on the borderline between IETF and IRTF in terms of the work that we've done, and has sort of graduated to the IETF to kind of handle that IANA naming. So I think looking at the example of OPRF and hash to curve, where the domain separators are defined inside of the CFRG docs, but the IANA registry is at the IETF protocol level. It could be a model to pass. I guess the question is like how these labels themselves in IANA are meant for interoperability. Is this something that we are defining here in the CFRG level, or are we relying on upper level protocols to define code points for interoperability? The issue is the concrete docs are like on the borderline between research docs and protocol docs, right? And so we kind of stepped a little bit over into the protocol doc side on HPKE and then moved the whole thing there. The question here is like, at the end of the day, if other concrete docs come into play and they're written from IETF groups, do they have a common place to register to make sure they don't collide? And is that something that we need to define in these concrete docs or not? It's a good open question. I don't have an answer for it, but that's a little bit of the history behind what we've done in other things.
So just, I think to respond to Nick, I think it's sensible to, I mean, so if, I guess if every every variant of one of these schemes is going to end up defining its own label, I mean, one question is should it, but assuming we think it should, I think the polite thing for us to do would be to define this IANA registry ourselves. Otherwise, someone else is going to have to do it. That might happen at LAMPS. That might happen somewhere else. That might happen at HPKE. I don't know. I think just going first is it would be the polite thing to do for the rest of IETF.
Bas?
Okay, yeah, so back in Bochum, when we were sat in front of a whiteboard, counting the bytes in the RAID of SHA-3, we noticed there were a few bytes left. And then we thought, oh, wouldn't it be fun to have some ASCII art in there, right? So that's the reason it exists. And we didn't name it a domain separator on purpose. We named the label. And if you look at generally in cryptography at different levels where it happens, if you look at cryptographic primitives like MLChem, there's it's the domain separation is really minimal. It's just different enough, just maybe one byte different enough so that they're separate to help the proofs. But the further down in the stack you go, the more domain separation is sprinkled in for a feeling of safety, where I really question whether it's that well thought through. And in the case of composites, if I mean, there's not domain separation anyway between different chems anyway as you use them. It's just because we happen to be able to do it here, we should. I'm not sure. I kind of regret the ASCII art label now. I mean, if we had left it out, then we wouldn't be discussing it here. So I really don't care.
Yeah, hello. To sort of follow up on Bas, I do think that there's a little bit of difference between the design of X-Wing and a generic mechanism. I was thinking about it a little bit during this discussion, but the annoying thing is that we could have a situation in theory where we have some combiner and some other combiner for the same primitives, and that has a public key format that's the same. And that kind of situation is, I mean, usually it breaks. Sometimes it's extremely bad. And then especially if then also the way that that's get fed into the KDF, because it somehow has the same transcript, that is the bad situation that you would prevent if you have some sort of separator. It is also true, as Bas said, that it is not free. I mean, you will spend more CPU cycles if you hash in, especially if you go past this SHA-512 rate or whatever. But it probably makes sense to do something. It's my take.
I'm next in line. That reminds me of why having a registry is not just we have a IETF-wide registry so we don't collide with each other. If we have a registry, we can have shorter labels that actually get sent into the actual KDF that we're actually hashing. Right now, we've been writing them up as like QSF-MLChem-X25519- Shake 256 or whatever, like a long label that's like encoding all the ingredients to separate from other possible concrete instances of QSF or whatever. If we have this registry, the way that we've currently sketched it out, it is registering the framework, the ingredients, the KDF, the PRG, which is for key generation, the sizes, which would allow us to just pick a random non-colliding, 8-bit like single byte character. Theoretically, we probably need more than 8 bits, and have like a very, very minimalistic, basically encoding, because we've figured it out via the registry. So that's a benefit to having the registry, beyond just it's good for IETFers to not step on each other's feet when they're doing concrete hybrid chems, and we get the niceness of actually encoding it into the label that we concat into the KDF input. One other thing I wanted to note is there's other ways to domain separate, and that's length. But the actual length of the input going into the same, hash function or KDF or whatever, if those things diverge, then they have been separated. But that's a little bit harder to do generically like this. So the label seems to be a nice way to do that. So thank you. Do we want to do a show of hands?
I'll set that up. Yeah, Tom, you had a question to me about my comment.
Right.
Oh, just for later, for you to check in the notes that I got it correctly.
Okay, great.
Same question to Deirdre, actually, because typing up what I said and then you were talking was very confusing.
Sorry.
And the question here is specifically, should we do so in the concrete draft, right? Rather than in the generics draft?
I think, do we set up the registry in the generic, right?
Yeah, we would set up the registry in the generic document, and then the concrete doc would register the first few code points in it.
Yeah.
Okay. And to Deirdre's point, we might choose shorter code points if we have a registry. Code points as in strings.
I have a feeling that ASCII art will continue to live, though.
It will.
It's going to be a numerical option here as well?
I mean, that is an option, as I think I laid out in the issue I wrote up. But if you go with numerical, you do get more brevity, but then you have a constrained space, and so you need to manage it more carefully. Unless you do like giant.
It's the number of options for each of the parameters, right?
Right. And you have the question of interop with X-Wing. So I think strings are probably more flexible here. Yeah.
Okay, the poll's still open. Please vote if you have opinion. If you have no opinion, vote no opinion. So far, nobody's against the registry being registered.
As Mike notes, if LAMPS is going to define some more concrete instantiations, they would also register some new labels in this registry. And Mike, with regard to fastitude, I think we're hoping to get this out in the next order weeks, depending on how fast Wood and Patton get their implementations done.
Okay, so it's mostly yes, a lot of no opinions. Let's go for it, and at least propose this in the generic doc. If process people push back, then we can have that discussion later. But it seems reasonable. The group has some consensus around this.
All right. We have 3 more issues here. This is I think the last 3 are a little bit more substantive than the ones we've done so far. So this is something that came up in the discussion with LAMPS folks. In the document, we specified this shared seed keygen, where you generate a random seed, and then you expand it into seeds for which you derive keys for the 2 component algorithms. Folks who use HSMs a bunch in their daily lives noted that you cannot implement this if your HSM only implements a generate key pair primitive as opposed to a derive key pair primitive. And so, like, the thing you can implement in that is this separate scheme on the second line here, where you generate a post-quantum key, generate a traditional key, and then you treat the conjunction of those, or the concatenation, or however you want to make a tuple out of them, as the private keys. The thing I've bolded here, the seed is the private key, or the tuple is the private key. There's some disagreement there as well. The question, there's an editorial question and a substantive question here. Editorially, we can discuss like how should we describe these things. I think in the discussion we've had, there's pretty broad agreement that like shared seed should be the default thing. We should guide toward that and have separate as an option. The more substantive question is whether these two things should interoperate. In principle, you can implement the same NCAP and DCAP operations regardless of where the keys come from, regardless of whether you do the shared seed keygen or the separate keygen. You could also basically force those to not interoperate by, for example, using different labels for the two cases. There's also, I think, some scars here that folks have from the MLChem private key format wars, not wanting to have multiple formats of private keys around. So yeah, I think there's a question here about interop, how we talk about keygen here. I think Deirdre and I probably end up on slightly opposite sides of the interop question. I would use the same label for this irrespective, because the NCAP and DCAP are the same, and the claims about keygen are only ever a promise. But I don't know, Deirdre, what's your take on why we should break interop?
One basic property that the single seed that you put through a hash or a KDF to expand it, we explicitly call it a PRG, a pseudorandom generator, in the documents, because it has a slightly weaker, you need slightly weaker properties from it than like a PRF or a KDF or whatever, is it really tightly binds the seed as the decapsulation key to the public encapsulation key that you produce, and gives you these strong binding properties, but it also makes like these kind of mix and match attacks, or downgrades, stripping attacks of hybrids a lot more difficult, nigh impossible. So I think we explicitly write up, but I'll have to double check. If you use the seed-based variant, you can get very strong binding properties, which for some might be overkill. Like some of these mal-bind properties are a little bit overkill, but it's a little bit more that is indicative of the strong resilience to this sort of stripping attack or separation attack, or the inability to avoid the temptation of taking an old key that you've had lying around and smashing it together with a new key, that might be your post-quantum thing, and using that in a hybrid setting, which is not really good. We don't really like that kind of stuff. So especially when you're looking at the whole chem as a cryptographic primitive, and that includes the keygen and the NCAPs and the DCAPs. The properties of keygen and how it's being used, how the resulting keys are being used in NCAPs and DCAPs matter about the whole scheme's security properties. Maybe going from mal to leak or not having mal is you don't care about that, and I can understand that. But the sort of signal that it changes the security properties of the whole scheme by changing the keygen, or allowing two different kinds of keygen for one scheme, I feel like is a signal for something that these things have a significant change. However, we're writing a document, so I think we're spitballing a writing down seed-based, which, having just talked to some people at NIST who are working on an update to SP 800-133, I think, they're explicitly going to allow seed-based keygen for FIPS applications. I think the caveat is that the CRG, the seed expander, has to be a NIST approved KDF, not an XOF like Shake, which is a big bummer because all the concrete instantiation of X-Wing could have been all FIPS if they allow that. So we'll see. Making the seed-based keygen sort of like, here's the keygen we write down. And then underneath we say, if you can't do this because one of your component algorithms is stuck in a piece of hardware and you can't hand it some randomness and say, spit me out a key, to your fully encapsulated process. Like, you have to have keys coming from one place and keys coming from another place and then putting it together. You may do that with the understanding that, this has different security properties and yada, 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 yada. I think that's where we're kind of circling. I think we literally have that language in 2 different places in those 72 and 79 drafts, and maybe one more PR or whatever. I think that's where we're kind of circling around, which is that, yes, these are different, and we're going to caution you about the differences, but also kind of allowing you to make that choice, especially for future concrete instantiation authors. It's most relevant for them. Although we've already heard about people who are like looking at, say, the X-Wing draft and saying, yes, I'm going off book. I'm doing keygen differently than X-Wing, but I'm fine with that. And it's like, okay, well, you can do like, and the X-Wing draft doesn't say you may do that. It says like, this is keygen. This is the only keygen. So I think that's where we're kind of landing at the moment. What do people think?
If there's no questions, I can do a show of hands. If this is well over your head, there's a no opinion option.
I think the question is seed-based keygen with a may do something else, caveat emptor, or something like that. It's like, how do you feel? Yes, no opinion. Mike?
Richard's sending me to the mic with the comment that I just posted. So, like, seed-based makes sense to me if you are writing software from scratch. Like, if it's an entirely software environment and you're implementing this brand new, both the PQ and the T sides are brand new, cool, fill your boots. But to me, like, the customers who want hybrid, it's because they have some battle-hardened traditional thing that's been deployed for 20 years. It's been through 1 billion audits. They want to be able to tell their auditor, look, we're adding a thing, but we're not removing anything. We haven't changed the old thing. Look, auditor, go away. Nothing changed. Like, so if you're going to... I don't have any crypto library in prod today that has a seed-based ECDSA or ECDH keygen. Like, that doesn't exist in any library I use. So if we have to go back and patch the traditional thing to do the seed thing, then to me this is useless. I can't use it. So like, I'm not convinced that seed-based really is the default thing that is going to be used. That's it. Over.
Just one point of clarification on the show of hands that was just started. Distinct labels means non-interrupt. And yeah, I think even if we have same labels, we can have the scheme that Deirdre just mentioned, where we describe the default scheme and have appropriate warning labels around the separate generation.
Yeah, feral interrupt and warning seems. Maintain interrupt and warning seems right. So
maintain interrupt would be same label.
Yeah, I think that's
okay.
What everyone's saying. So it's 10 votes no to no, 0 to yes for different keygen means different labels. So different keygens should be identical.
Okay.
With labels.
Okay.
Okay. Clear feedback.
I'm catching up on the chat. The point of PQ traditional hybrid is so you can bolt PQ onto your existing deployed traditional code. I don't necessarily agree. I think PQ traditional hybrids are to be secure against a attacker, a classical attacker, if your PQ crypto is deployed too early. The software is not mature because we just are not very good at doing these re-encryption checks in a secure manner. Think of Kyberslash, or structured lattices there's a little bit too much structure in there, and boom, lattice sieving breaks it in a year or two. Deploying onto existing code is like, I don't know if that's necessarily like part of the goal. It's the security assumptions of, we are belts and suspenders, we're deploying PQ fast, and we have the security safety net of classical cryptography just in case we're going too fast. Right. Multiple reasons to do hybrid compliance, reduce risk. Sure, but I don't know if compliance necessarily means bolt on. You can be compliant and not bolt on. I understand the impulse completely, but yeah.
But in any case, I think we got feedback from the group, and we can take that and
yeah.
All right, next issue, fallibility.
Is this a quick one? Just because we're going to take a break until the top of the hour in 5 minutes or so.
Oh,
I think so.
I think so. I think we could probably handle this in 10 minutes or so.
Yes.
I think we only have one more issue after this, so it's up to you.
Yeah, let's go for it and then take a break after this.
Cool. Yeah, so as folks who have dealt with some of the PQ chems know, they can have decapsulation failures with very, very small probability. Some annoying chems tried to hide this by this implicit rejection stuff. I think this is like really annoying from a programming point of view, but question is what should we do in this document? Should we say like, hey, watch out, this chem might fail, be explicitly fallible, return, for those rest heads in the audience, results T instead of just T, or should we just say, don't worry about it, it's negligible. Like obviously it's usually good to be explicit, but if you look at like what the TLS folks have done recently, like recent TLS working group discussions, like let's not even bother, thinking about this case because it's cryptographically negligible. Oh, and Paul may be raising a point that I failed to capture in this slide. So actually I'll hand over to Deirdre, and then maybe Paul wants to come to the mic here.
Sure. So for an example, MLChem is implicit rejection. I think the latest draft of HQC, which is also going to be a FIPS, is also implicit rejection. So what this means is when you do decaps, it will always give you a pseudo-random value. That pseudo-random value it's always a, at least for MLChem, is like a 32-byte bag of bytes that is better than, a 0 or a 1 or some other, code that you might, if you don't know any better, accidentally try to coerce into key material or start doing, record encryption traffic and things like that. The idea being that, one, it's good for proving in CCA-ness, is that your theoretical adversary in the security game still can't tell which one, if you gave the quote real key or the FO transform rejection value key material, and it's good for proving that. The other thing is that, so TLDR, there are no chems floating around in kind of standards that are explicitly explicit rejection. They are all, including like classic Michaelis and Photochem and things like that, they're all implicit rejection. So the API is always, you do a decaps and you always get out a value. There is no error code. The only time there's an error code is because someone implemented it wrong, like the first submission of HQC. which had an implementation bug and an NCCA issue. That was annoying. They have fixed that in the updated reference implementation. This other part is that chems may, such as MLChem, have a teeny tiny possibility of just failure. Everyone is honest. Everyone does everything correctly. All the randomness is good. And like with the probability of less than a cosmic ray bit flip, you may fail decapsulation or decryption and just not agree to a shared secret via MLChem. I think there's been discussions around IETF that basically say, one, a human implementer can never detect this and can never handle this. And so telling them about it and telling them, like, be aware that this may happen is kind of, you can't do anything about it. And if it were to happen, what would happen is that one of the computations would fail, decaps or ncaps. And then if you use it in HBKE or TLS or something like that, you would be using two different keys to encrypt and decrypt traffic, but they would disagree with each other. One person would be able to encrypt and one person would not be able to decrypt. And then you throw some other higher protocol error like you would in TLS, and then you either break the connection or you stop doing the protocol or something like that. So my opinion is, one, chems are implicit rejection generally. All the designs, chems that we are discussing for the most part are all implicit rejection. All the designs that we have written down for the existence of these documents so far have assumed implicit rejection in their designs. And three, we don't say anything about the low possibility of failure because the implementer can't do anything about it anyway. So.
Tom, thank you.
Yeah, so the Rust heads comment kind of reminded me for a MLChem implementation or Kyber at the time that I saw where someone thought, oh yeah, I'm doing this in Rust. I should totally return a result for MLChem decaps. Adding that pattern to the API for the chem combiner, I kind of see someone starting with the hybrid combiner outside, looking at that, then going for the innards and implementing some bad MLChem or HQC or whatever chem comes down that has implicit rejection and re-adding the explicit rejection again. So that makes me lean towards more implicit rejection, more better. There are people in the comments that are complaining about RSA. I mean, I understand complaining about RSA in general, but in this case, they're complaining about that. It seems to be explicitly rejecting. So there seems to be something to be reconciled there, but I don't know any of the details. So if Mike wants to say more about that, then that might make sense.
Sure. Hi. Right. So this is brand new. I've thought about this for exactly 3 minutes, but I'll think about this more as the labs thing gets closer to working class call. So yeah, RSA OEAP can reject if the padding is wrong, right? If the ciphertext is borked, it'll get detected and it'll reject, which I think makes it an explicit rejecting unless you do some fancy wrapping to make it implicit. Is this a thing we care about? Is this a thing that's worth delaying the labs composite draft and reworking the test cases and sample code and blah, blah, blah? Like how important is this? Looking for guidance. Thank you.
So all the proofs for all the constructions, including the current one we have that's taking an NCCA2 public key encryption scheme like RSA OAP, just passes through whatever it's doing. It just assumes that it will always give us a usable shared secret. And then we use that in the hybrid construction. It sounds like that is a kind of internal construction detail of using RSA OAP as an in CCA chem. We sketch it in our current proof document about how one does that, but like really lightly. It's just literally, if this is an in CCA2 PKE that looks and smells like implicit rejection, because implicit rejection, explicit rejection are kind of explicitly notions of FO transform chems. We model it as an FO transform, or we model it as implicit rejection. There's no notion of rejection. It's just completely pass through. I think that's a detail to be specific about that.
So I'm cognizant of time here. Maybe we take this over to Lamps, but yeah, I mean, I guess the security risk is you find out which ciphertext failed. If like the RSA can explode with an exception and the MLChem can't, then you get to learn something. That's the problem here. And if we want to hide that,
then that has NCCA implications. So yes.
Yeah. All right. Let's fork this over to Lamps, because this sounds like I need to change the algorithms and change the samples, and this sounds like a pretty major change. Yeah. Okay.
Maybe.
Mike remembered something stupid. I think that there's a case in which MLChem decaps will return a failure code, namely if the length of one of the keys is wrong. Something stupid like that. So yeah, not sure how you want to handle malformed inputs, because I'm pretty sure that the FIPS standard made you check the inputs before you did something. And I think that it will actually return error code if the inputs are just not plausibly an MLChem input.
Okay. I'm going to go log an issue on the Lamps mailing list so that we have a pointer for this, and then let's continue with our life here.
Yeah. I think basically all of that is before, at least in 203, try to map it onto the things that we have proofs for. All of the key format checks are before you get into the decaps algorithm. So yeah, it's fine. Assuming you have a well-formatted key, then implicit rejection, blah, 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 blah. Cool. All right.
Paul?
Should I wait, or can I add something now?
Go for it. Add something. I'm just going to run the show of hands after this comment.
Oh, okay. I just wanted to say, I mean, to me, like, I don't think any of the IND-CCA proofs rely on explicit versus implicit rejection. I mean, I think what Deirdre said, like, if you just pass through the failure, if it occurs, is what implicitly I think is assumed in all of the proofs anyway. And the fact that it doesn't, none of our reduction seems to hinge on a failure symbol showing up or not. So like the fact that doesn't show up leads me to believe that it's like not important. Really what's important is just like literally like the pseudocode of the decaps routine in the spec. Like, does it ever return failure, or do we design it to always implicitly reject? And the private key includes a PRF key that we can use to derive like a fake shared secret or not.
Yeah. I think everything currently as designed is similar to how it is in X-Wing, which is like anything that happens is just surfaced automatically to the external API of the hybrid chem. I don't think implicit versus explicit affects any of the proofs. It is the doing of implicit is supposed to be more of a security and practice consideration, so that like literally whatever bytes you get out of decaps, it's much safer to always have 32 pseudo-random bytes than sometimes you have 32 pseudo-random bytes and sometimes you have a 0 or a 1 and your code might not correctly handle parsing of error codes, that sort of thing. Yeah, I think you're right, Paul. Yeah, any chem that cares about it should already be implicitly rejection, not wrong code minor. Yeah.
Mm-hmm. Yeah, I mean, for me, setting aside the implementation questions, leaving the failures as pass through and making our API, I guess, okay, confusingly, I guess this would be implicitly, explicitly rejecting, because it depends on what the underlying chems do in terms of rejection. But that's the way it is now, and I guess I don't really see a reason why it shouldn't continue to be that way. Yeah.
Cool. Show of hands is up.
Yeah, I'm not sure the show of hands is really capturing the question I want feedback on. It sounds, but it sounds like maybe the middle of the road position here is to not have any preference for whether a given chem returns a failure symbol or not. But if you do get a failure from one of the chems, then the overall hybrid chem fails. So you would pass through errors, but not have any opinion on whether the underlying chem will actually return you one.
Yeah.
Does that sound plausible to people?
Yeah. Chris Wood says, doesn't that mean it's explicit? Yeah, I think so.
Yeah. You would end up with an explicitly fallible hybrid, where maybe not all the components would be would ever use that error branch. Okay.
So quick question here. Chems with failure modes are new across the entire IETF, right? So have other groups made decisions with respect to this implementation choice? Like TLS, for example?
So the TLS chooses to ignore the fact that an alchem can, and just say that carry on the protocol, fail if it fails. It's an extraordinarily unlikely thing. So
yes,
don't bother thinking about it.
TLS is going on a parameter by parameter basis. It has registered MLChem by itself and the hybrid constructions that are elliptic curve Diffie-Hellman plus MLChem. And I think the group has explicitly been like the possibility of failure, not the possibility of a generic explicit rejection chem being a thing, is so negligible, and it would, if it happened, would cause TLS to basically fail to decrypt record traffic, and then it would fail. It would throw like a incorrect MAC error or something like that. They're fine not including any language to any implementer about be aware that there's a minuscule possibility that everything done correctly will fail, and you should be aware of that and handle it somehow. I think they've explicitly said to not say that sort of thing, because what can you do? In terms of, I think the RSA-OAP thing is like the closest we've got to this can fail because of padding, but maybe we can I don't know, talking about that in lamps or
Paul?
Your keyjet, I don't know.
Paul Grubb?
Yeah, well, I was gonna say RSA OAP has been around, and it can fail on a bad ciphertext. I think the question is, well, it seems like it's relevant that there are correctness failures. Like in the all honest case, there are still failures versus like if you're being attacked, there's a failure. I guess from the point of view of API design, doesn't matter that much. But yeah, so I mean, I guess the point is that TLS sort of like externalizes the failure to the protocol, which, well, I guess that's what we're doing here, right? Okay, Daniel says prefer to have it implicit. Daniel, do you want to say more about that?
Oh, we have a list here. So
Oh, I'm sorry.
Yeah, Russ is up next.
So we've have dealt with these minuscule, when everybody's acting honestly, failures for a very long time. DSA has that case where, like if you generate a K and make the signature, it can still just not work. But it's also of a gamma ray hit your CPU chip kind of likelihood. And we've just not talked about it in the protocol documents because what are you going to do? In that case, you actually could generate a new K and re-sign, but at an API level, that's really painful. Anyway, I think ignoring those minuscule when everybody's honest, there's precedent for us doing that for decades.
Chris?
Yeah, I had a few thoughts. So I'm definitely in the implicit rejection camp. Historically, like exposing too much in an API has been like attack surface. So we should be mindful of that. But when it comes to RSA and like the existing drafted lamps, like, do we need to do anything about this? I think is a good question to ask. Like, I think we should be clear about like what property we're actually trying to achieve. So Deirdre, I want to put the question to you. What goes wrong in terms of IND-CCA security if you you have like you're using some hybrid chem and RSA OAEP is the traditional part and decryption fails because of the some internal thing. What goes wrong for IND-CCA security of the combined thing?
So I think you can prove in CCA of such a construction. I think Paul mentioned this. It doesn't necessarily imply anything about the in-CCA-ness because there are plenty of generic and concrete explicit rejection in CCA chems that exist. So you can do that fine and still be in CCA. It's definitely just, it changes the API from just input decaps key, input ciphertext to the decaps algorithm, spit out a shared secret value no matter what. In implicit rejection, it's either the real one or the FO rejection value that samples randomness in the key and the ciphertext, basically. Or it's shared secret and code. It's results. In the Rust parlance, it's result wrapping your possible shared secret. So it does not necessarily affect the in-CCA-ness of the construction, but it does kind of affect the kind of practical, how do you hold the thing in practice? Oh, by the way, check the error code. Don't use that. Make sure you check the error code, as opposed to there's a single thing that's pretty good, and the end result of if you're using the FO rejection value, or if there's some weird failure, is that you use the rejection value, somebody on the other side is using the real value or the other value, and you don't agree. And then the protocol has some already failure mode of, can't decrypt. And so, and if I'm wrong about that, please correct me.
I mean, it would be nice. Okay, I don't fully understand the issue, I have to admit, but it would be nice if whatever we're doing to accommodate, like, I think I hold the view that RSA OAP is legacy in this context. If people need to support it, we should support it. But I think the work should be on, like, we should be thinking about workarounds to make it work for RSA OAP that don't affect everybody else. Okay. So that's the direction I hope we would go in. Thanks.
Paul again, or Chris Patton?
I think Tanya.
If not Tanya.
Oh, okay.
Yeah, if those are old hands, I'm happy to talk. Okay, so definitely want implicit rejection because, I mean, this is how they're designed. But I think one difference to things that we've encountered earlier is that for instance, the DSA example that was just mentioned, we had a way of finding out what went wrong. So depending which algorithm description you follow, there's either a loop which chooses different nonces, or you check that the nonce you've chosen was not invertible, and therefore you know why it failed. In the case of those CAMs with decryption failures, there is no way that you can find out why it failed. And you don't know that it failed, you just get a different value. So there is a small difference. Now, what people are doing with a failed decryption, I mean, where they get the different value, you break the connection, you try from scratch. Sure, it's not that you're going to call the starfighters and send somebody else. I mean, you should know before you send somebody to say, oh, I'm under attack, that this can happen with benign cases. On the other hand, if something failed, you're most likely under attack, or somebody just messed around with the intent connection. So there is a difference from what we've seen before. So I'm in favor of having a warning there, just because it's something really different from what we've seen before. In everything before, we could check that there was something, malformed message or not invertible nonce or something, but you could check it home.
Chris?
Just to reply to something Chris had said, I agree with the principle of hiding as much as possibly can behind the API. And if that were the primary motivation, doing something implicit makes sense. But in like all the cases that we know about or are discussing here, like the information that you're hiding is like immediately revealed, like 2 steps later in the protocol. Either the TLS finished MAC doesn't check, or decryption fails, or the way in which you're using the shared secret ultimately is invalid. The application has to deal with that after the fact. So I'm not really sure I buy the argument that you're like hiding things from the application when the application has to deal with this failure one way or the other. So like that's why I kind of lean towards, or I guess I'm more strongly leaning towards like I'm not gonna call it explicit, but like the pass-through approach, which is like whatever happens down below, just pass it on up. Don't go out of your way to like intentionally hide things. But if there's like a situation or a protocol in particular where like this the subsequent steps that the application may take in the implicit case with the shared secret that happens to be wrong, it is somehow different than what the application might do had it learned about the failure earlier. I'd be curious to hear that. And I don't consider TLS to be that case. Like it's true that like even if you did like make chem errors explicit during decapsulation in TLS, the implementations have already chosen to just rely on the finished message to deal with that, and they just kind of like ignore the warning or the error in this particular case. I don't know, but also at the end of the day, like if this is like an API question, it seems to me like applications can ignore stuff all day long and they can do things wrong. So I don't have a strong opinion in terms of like what is the correct API, I guess. But anyways.
Tanya?
Tanya, you can go up again, and then we'll close it out, and then we'll meet at half hour on the clock after this discussion.
Yeah, happy to take this one up. So to speak about the bad old days when we had lots of these things, there's PKCIS version 1.5, where we had these different ways that something could fail. So it could fail on the pattern, or you could fail on the last check. And if you would be giving information, this is like one of those nice exercises you get in a CTF or something. You can actually use this as a decryption oracle to find out when you failed. Similarly, with these lattice attacks, you can often, if you know exactly how it failed, break the thing. So it is important, if you're an attacker, you know that you messed with the ciphertext. So it will fail. So that part of the information, I agree with you, you learned something that you know anyway. But with explicit rejection, there's always the concern that you're telling the attacker how you failed. Did you fail on the decryption, did you kind of not get a valid result, or did you fail on the CCA check? So there's always this check whether your ciphertext is valid, which comes after you've been trying to decrypt it. And if you're failing the first part, it's different from failing the second part. So if your algorithm or your implementation leaks that information, you're giving information to the attacker, and we've seen practical breaks of this. So for instance, there was a HELA 5 submitted to the NIST competition, which we had fun breaking as one of the first ones. There's Entry implementation, which had that issue. So, I mean, like if you take this away from Entry, then you have this issue. So implicit rejection is really a security feature. And it's something which, well, is there because we have had the bad examples with the PKCS 1.5 versions.
Nick, you want to summarize?
Yeah, so I think we can maybe skip looking at the question that I asked. It doesn't seem to reflect the type of answer or the information that we need here. But yeah, I guess we've heard quite a lot about implicit rejection being a good thing. I don't know. I'm not sure if there's a final decision here. What's your take on it?
Well, if I can, sorry, Nick, if I can just, I'm going to do something unwise and assign myself work. One thing I would like to understand is the consequences of these two different decisions for related like chem scenarios and these timing attacks. So I'm going to try before we get the next draft out to like do a literature review and try to understand what can go wrong a little bit better. Yeah, I mean, I still suspect that the right decision will be what we're doing now, but I would like to understand a little bit more. So
I think Tanya's latter point about not revealing more information than having opaque errors, not passing things up. That's also a good thing to capture in the doc.
Yeah. Okay.
Okay. Well, that was a longer discussion than we thought, but I think very, very fruitful. Good feedback. This is a difficult question. Okay, so let's come back at the half-hour point and then go through the last couple of things we have on this document on the presentation.
Okay.
See you all in 12 minutes.
See you.
So as people are coming back, I pasted a kind of summary resolution into the chat about kind of the way the author were going to interpret the last, the conclusion of the last point. So please speak up if that doesn't sound like the right conclusion to you. Or speak up in the chat. We can move on with the overall discussion. Nick, did you want to declare us open again, or?
No, I think we can just hop on to the next one. But yeah, thanks for summarizing. It's all in the chat.
So the last issue we had is about pre-hashing. So as we said earlier, we removed the pre-hashed variants because there wasn't feedback at IETF was that there wasn't a lot of energy for it and people were more interested in simplicity. In principle, we could re-add this as an appendix. There are, in principle, some use cases where it adds some performance benefits. There are some sketches of proofs on the mailing list, though we want to make those more precise. Yeah, I mean, if anyone wants to have this around, we could add it, but we would need to take those security arguments that were sketched on the mailing list and give them some more precision. I think Paul Grubbs may have thought a bit about this, may have some color to add there, but yeah, we would need some argument there. Discuss. Deirdre. Tom.
Go, Tom. I have nothing.
Yeah. I don't believe in appendixes. This is adding a fifth scheme to the document, and I think that doing something like that means that it deserves the same amount of attention and detailing and checking the proofs and all of that as any of the other proposals, because it's in the same document. People are going to see it's in RFC blah, not that it's in RFC's blah's appendix. They're going to lose that detail, especially that appendix might warn against doing this because it was less scrutinized or something like that.
Fair.
Is it not enough to note that we have this, and then down the line, if someone wants to do this concretely, dig it up, make a new draft, maybe even to do this, and apparently that at that point there will be the energy to do it properly.
So you're saying the content of the appendix wouldn't like fully specify it, but it would say, you know, this was something that was discussed. It would be, actually, we already have a section in there. It's like paths not followed. So we could have one in that says like, this was something that was discussed and we didn't end up doing it. If you wanted to do the analysis and do the actual work, you could do it there.
Maybe that would work, but the way that I read your slide was explain how to implement pre-hashing. And I would not argue for doing that.
Yeah, okay, thanks. And I believe Stephen Farrell in the chat before he left said that he was not in favor of adding an appendix. Other folks have thoughts?
Can you be more clear about what you mean by describes pre-hashing? Like programmatically, textually?
I mean, you could, we could do anything on the spectrum. We could say pre-hashing is possible, no further statement. We could have pseudocode that describes concretely how you would do it.
And so the feedback you just received, was that about the concrete or the like general description?
Yeah, I think the way I was understanding Tom's feedback is that we shouldn't be real concrete here, because that would encourage people to think that this is a real thing that has had good scrutiny, when in fact it hasn't really gotten the same level of consideration as the other constructions in this document, unless we go to do a whole lot more work, which we may not want to do. So the way I interpreted Tom's feedback is like we should not do the super concrete thing, but maybe it's okay to have a hand wavy thing in a paths not followed section.
I know this was discussed a lot on the list. Are there any relevant points that folks brought up who were very strongly in favor of this that you'd want to share with the group?
Yeah, I mean, I can speak a little bit to that. So the objection raised by people who are pro pre-hashing is that there actually is no additional work to do on the security side because of like some kind of indifferentiability argument. Well, like I mean, I think not having a strong grasp of the indifferentiability results, I think that that's possible, but I think like verifying this claim to the extent that we could have confidence in it in basing the security of a construction on it would be almost as much work as writing a new proof, which is to say that it would be quite a lot of work, especially when you take into account quantum indifferentiability and things like tightness, which is sometimes a problem when you apply these results. So yeah, I mean, I guess like this is why I lean towards having some kind of maybe very brief discussion as Tom suggested, deferring maybe to like another like iteration of a document or like a V2 that can do a more thorough treatment of pre-hashing and kind of do all of the very careful crossing, you know what I mean, very careful detail checking for these indifferentiability results.
I'll jump in here and I will note that ChemPat, I think which is sort of the thing that inspired the pre-variant that we wrote down and then removed, is the only one, okay, I won't say that. Pre-hashing public keys, which is what pre was doing, because pre-hashing the ciphertext is like, your ciphertext changes every time that you use the chem. The pre-hashing the keys, quote, makes sense over more than one decapsulation. Pre-hashing, which is pre-hashing the ciphertext, which is what ChemPat did as well, is only that ciphertext varies per decapsulation and encapsulation. So we did not write that down. It's not very common to pre-hash the public keys in a lot of hybrid chem constructions in the literature. There's been a little bit of pre-hashing of public keys inside a full-on FO transform chem in multiple layers, including in ML chem. I think there's some of it in HQC. And so they have a whole bunch of stuff about, the security of those hash functions and those, and that goes into their NCCA bounds and all of that sort of stuff. In hybrid chems constructions, it's less common to pre-hash public encapsulation keys, for what it's worth.
Okay, that makes a lot of sense. I think from a pre-hashing perspective here, we didn't discuss this in the initial design parameters for this project, so it's good that we're having this discussion now to go through it. I think we've all sort of decided to try to make this document or these two documents as useful as possible and compact as possible. And from what I can tell, there haven't been any like IETF working groups that have been really pining for something like this. Maybe I'm not aware of them, but it seems like every of the other three cases that we looked at had pretty strong use cases deriving from IETF groups that needed something of this shape. Do we have any concrete asks for this?
I don't know of any personally.
Yep.
But I'm not really deep in a lot of these IETF lists. So.
If I recall, I think the argument of which component chem this would be nice for was classic Nicolese, because they have very large public keys, but maybe I got that wrong.
Yeah, I mean, for this stuff to be useful, you need situations where you're going to have large public keys and have them be reused a lot of times. So, for example, if you were using classic Mikulicz keys with SSH where people configure decaps or configure keys and leave them for a long time, like that could in principle be useful there. But I don't think that we've had someone from that community saying like, we want to deploy something in that framework, and we would be good to optimize for that.
So a counter argument there is that we now have proofs of the C2 PRI-ness of classic Mikulicz. And so instead of using pre or a pre-hash variant, you could use one of the two schemes here that rely on the C2 PRI-ness of the post-quantum chem. And you would not need to include the public key or the ciphertext in the KDF there. So, but then that assumes you trust the C2 PRI-ness and are comfortable with that, as opposed to say GHP or the other one, the other new one, which does not rely on the C2 PRI-ness but would still be including the large public key.
So Deirdre, are you saying there would be no difference in pre-hashing versus not in the C2 PRI optimized construction? I
think it would be more efficient. I think the C2 PRI assumption constructions would be even more efficient than pre-hashing, because you would never, there's no pre-hashing of anything. You're just relying on the ciphertext collision resistance of the post-quantum chem classic Mikulicz to allow you to just not include the classic Mikulicz ciphertext as well as the well, okay, I want to be clear. The inclusion of the public encapsulation key for both pure chems and hybrid chems does not actually affect the in-CCA-ness of the construction. It is about multi-target attacks and other things about binding to the public key. So including the hash or the pure raw public key into your KDF, either as a pure chem or as a hybrid chem, does not necessarily impact the in-CCA-ness of the scheme. It does have other security effects, and like there's a reason that in the evolution of ML Chem, they originally hashed in everything, like hashes of hashes of hashes, including of the public key. But then as it moved from round 3 Kyber into the ML Chem draft, they removed the hash of the public key in its key schedule because it made computing the bounds of their actual in CCA proof easier and tighter. They had a nicer, cleaner proof as part of the reason they did that. So, yeah. But it would not affect, it would be cheaper to use the, I'm forgetting which one is which now, and I named the damn things. The one that is basically QSF, but allowing, no, the other one. If you're relying on C2 PRI, it's even more efficient because you're not doing any hashing of a 32 kilobyte public key or however large the classic Mikulicz public key is at all.
Gotcha. So you're saying that if there was a pre-hashed version defined for all of these, it would only be relevant for the non-C2 PRI instructions.
Correct.
For which we don't have as many examples that are popular, that people are looking for, versus C2 PRI, which seems, if this classic Mikulicz thing is true, puts like our whole bundle of most popular chems into this bucket, right?
And you know, it's contingent on whether you want to trust in that additional security assumption. And it's pretty straightforward. It's literally the second pre-image resistance of the internal function inside your post-quantum chem. So, you know, it's not a huge novel security assumption, but it is not just plain Jane in CCA. Like, you know, if you like your plain old, you know, comfortable in CCA, you use something like the GHP construction. That's all you're assuming, and you assume the security I think it's the split key pseudo randomness of the hybrid chem KDF. Some people might be like, I don't want to trust in the C2PRI-ness of classic Nicolese. I don't trust it or whatever. But if you do, you can do this and you don't have to worry about prehash.
Okay, so I think the open question here is, I think we sort of eliminated the idea of having an appendix that has full pseudocode for this and test vectors. But the question is, should we mention this and talk about how it works without pseudocode or even without a proof? Does that make sense for a show of hands?
Yeah.
I just clicked the yes button only in the sense of like, documented as a path not taken.
So it's coming through. Any more votes? Yeah. It seems to be that no is the majority, but not by much. So I don't think it's crystal clear.
Can I ask make a really outlandish suggestion that might end up not being very helpful? If we just put the public keys first in the hash, implementers can choose to pre-hash them because they can ingest them into the hash state first. And that would basically make everyone happy as far as I can tell, right?
That would definitely hurt with fixability.
No. NIST has been super clear that the shared secrets need to come first, because if you put a thing that's variable length at the beginning, then things all get weird and screwy. Yeah, no, you cannot. It would be nice for performance reasons to put the public keys first, but no, you're definitely not allowed to do that.
Well, just to be clear, these are not, like, we've assumed that all the public keys are fixed length, so it would not be variable length, but probably still not good.
Yeah.
All right.
But yeah, that was honestly when I very first came to this problem and was trying to figure out what all the options were. Yeah, just putting the public keys first was a thing that came to mind, and I benchmarked it and it has similar performance to pre-hashing. In fact, if I recall, slightly better.
Yeah, thanks, Mike, for explaining that.
Yeah.
I think that's a good reason not to do it.
Okay, so yeah, I like Mike Ellsworth's summary in the chat, that we can just document that pre-hashing exists and it's something that someone might want, and not really go farther than that. So that's fine feedback. It's been a PR on that. All right, thank you for all that feedback, and that is the last issue we had. The last point I had on here is a timeline plan, which we already kind of said ahead. So we're going to try and, maybe not a week or two, but, order a couple weeks, definitely before the IETF draft deadline. And yeah, I think at that point, we'll need to update the concrete doc as well. That might take another little while, but I think basically in the IETF time frame, we're looking at these being ready for whatever the next process step is. I don't know if our last call is the right one, or if getting to the crypto panel or whatever. But yeah, I think ready to be considered, baked, and passed on to the next process step. So that's all I've got. Nick?
Yeah, I think the next, I guess, semi-official process step is getting once there's some broad agreement on the mailing list, it's going in the right direction and is relatively finalized as you're claiming that it is, then we would pick somebody from the crypto panel to do an in-depth review and have you address that feedback. And if everything's good there, we'd probably do a last call. There seem to be quite a few issues open on GitHub, so let's try to resolve those as fast as we can with the input of the group, obviously.
Yeah, I think I think what we had on this call was the major, we need to discuss what the right answer is here issues. The other ones are just to-dos. So I think the hope would be that the next draft will have all those issues addressed.
Any other business? Going once, going twice.
Thanks everyone for taking a big block of time today. This was super productive.
Yep, thanks everybody for showing up and participating and being active here. This is very useful for moving the document along. And we will eagerly await the new version of the draft. All right, thanks everybody. And Tom, thanks for taking notes as well.
Yeah. Thanks, y'all.